Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Tifr, Jest, IIT-Jam and other exams related to physical science. Okay. And this is the 12th part of this series of CSIR NET Physics 2021 paper solutions. Okay, and I'm solving part C questions. Okay, and also, guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. And also, guys, please share my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, so let's get started. So question number first is, so I'm solving part C questions of 2021 physical science CSIR. Okay, so question is, it's a good question. A particle of mass m, a particle, a particle of mass m, a particle of mass m in one dimension, a particle of mass m in one dimension is in one dimension is in the ground state 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 of a simple harmonic oscillator of a simple harmonic oscillator. Okay, a particle of mass m in one dimension is in the ground state of simple harmonic oscillator described by the Hamiltonian described by a Hamiltonian by a Hamiltonian Hamiltonian described by a Hamiltonian H equal to p square upon 2m plus half m omega square x square in the standard notation. in the standard notation in the standard notation an impulsive force an impul an impulsive an impulsive force at time t equal to 0 at time t equal to 0 suddenly suddenly imparts a momentum, imparts a momentum, imparts a momentum, imparts a momentum P naught equal to root h cut m omega to it, to it. The probability that the probability the probability that the particle remains that that the particle remains in the original ground state, in the original ground state, original ground state, original ground state is option A is e to the power minus 2, e to the power minus 2. Option B is e to the power minus 3 by 2. Option C is e to the power minus 1, and option D is e to the power minus half, e to the power minus half. Okay, so this is the question. A very good question, guys. Okay, I'll explain the question first. Okay, after that I will solve it. The question is a particle of mass m. Okay, a particle of mass m in one dimension, which is in one dimension, is in the ground state of simple harmonic oscillator described by the Hamiltonian h equal to p square upon 2m plus half m omega square x square. Okay, so a particle which is in one dimension is in the ground state of simple harmonic oscillator. Okay, and whose Hamiltonian is given. Okay, an impulsive force at t equal to 0, at time t equal to 0, an impulsive force suddenly imparts the momentum p naught equal to root h cut m omega to it. Okay, so the impulsive force gives momentum. Because of impulsive force, the particle gets momentum. Okay, at t equal to 0. Suddenly the what happens is an impulsive force at time t equal to 0. So impulsive force is given at time t equal to 0, that suddenly imparts a momentum to it. Okay, so that particle gets momentum. Okay, so that that starts moving. Okay, now the probability that the particle remains in the original ground state. So the probability that the particle remains in the original ground state. Okay, now I will solve it. So very good question. So now because particle is in one dimension, is in ground state of simple harmonic oscillator, right? So it means so particle as a ground state of particle, the original ground state of particle or ground state of particle before getting momentum. Okay, that is going to be ground state of particle, that is state, that wave function psi naught. Psi naught is going to be for simple harmonic oscillator, we know, right? M omega upon pi h cut to the power 1 by 4 and e to the power minus m omega x square upon 2h cut. Okay, so this is the ground state of particle before getting momentum. And new state, that psi p naught, the new state psi p naught is going to be, this is because the particles get a momentum p naught because of impulsive force at t equal to 0, right? So the new state of particle is going to be This is very simple because particle gets momentum, so that is going to be e to the power minus iota p naught x, my apologies, p naught x, p naught x p naught x upon p naught x upon h cut. Okay, p naught x upon h cut, then psi naught. So this will be the very important one. This will be the new state. This is new state. New state of particle after getting momentum. Okay, so this is the new state of particle after getting momentum. Okay, and this is the ground state of particle. Okay, ground state of particle before getting momentum. Okay, now we have to find the probability that the particle remains in its ground state, or the probability that the particle remains in its original ground state, right? So this probability is going to be, that is p naught. That value is going to be, p naught value is going to be this p naught that will remain in its ground state. Okay, p naught. P naught value is going to be simple probability formula, right? That is psi naught psi p naught, right? Okay, that psi p naught mod square of psi naught psi p naught, right? Okay, so p naught value is going to be, we'll put the values are this, right? So this is, so we can so this value is going to be mod square of integration, this one, psi naught psi naught psi naught p naught, this one dx mod square, right? So this value p naught is going to be probability that it will remain in its original state, that is p naught is going to be, so we'll integrate it. Or we can write this, that is square, right? Or we can write this one mod square of psi naught value we know, right? Psi naught value, that is integration, this is minus infinity to plus infinity. Psi naught value we know, this is the psi naught value, this is psi p naught value, right? So this is going to be m omega upon 5 h cut to the power 1 by 4 into e to the power minus m omega x square by 2 h cut into, this value is m omega pi h cut to the power 1 by 4 into e to the power minus m omega x square upon 2 h cut dx and mod square. So that so will now p naught is going to be, mod square will go inside, right? These are real values. So this is going to be Also guys, here we have this one P naught value as well, right? So this will be e to the power minus iota P naught x upon h cut e to the power minus m omega x square upon 2h cut mod square. Okay, so now we'll solve it. This is going to be mod of P naught values. So this will come outside. So this is going to be m omega pi h cut to the power 1 by 4. Okay, 1 by 4, and this value will be, this is going to be e to the power minus m omega x square upon h cut, because this is the one, right guys? Because these will get added, right? Because bases are same, powers will get added. So this is the value, this, and this n to the power minus iota p naught x upon h cut dx integration minus infinity to plus infinity. So just p naught then mod square, and p naught value is going to be, this will m omega pi h cut to the power 1 by 2. This will be 1 by 2. These will get multiplied, right? So this is going to be 1 by 2. And here we can write integration minus infinity to plus infinity e to the power minus m omega h cut x square minus iota p naught x upon h cut dx, right? So we have a formula, guys. This formula we know that we have a formula, guys. We need to note down minus infinity to plus infinity e to the power minus alpha x square minus beta x dx. Okay, this value is root pi upon alpha e to the power b square upon 4 alpha. Okay, so this is the formula. This one. Okay, so now I will put the value here. So use this formula. So this is going to be p naught value is going to be mod of, this is mod square. Okay, mod of this m omega upon pi h cut to the power 1 by 2. Okay, and this is alpha, this is beta. Okay, so root pi upon alpha, root pi upon alpha. Alpha means this m omega upon h cut, m omega upon h cut, m omega upon h cut alpha into e to the power, this formula, into e to the power b square. B square means this one, b square, right? This b beta x, right? This one beta x, b square. So b square means this this iota p naught x square upon h cut square, right? Iota is minus 1, iota square is minus 1, right? So this is going to be minus p naught x upon h cut square upon 4 alpha, 4 into this one, m omega upon h cut. Okay, so and this mod square. So P naught value is going to be, so this is going to be m omega pi h cut to the power 1 by 2. Okay, 1 by 2 into this value is going to be pi h cut upon m omega to the power 1 by 2. This will get cancelled. Okay, and this is going to be e to the power minus h cut will get cancelled. Okay, and this value is going to be p naught x okay, p naught, just a p naught, guys, the L beta value, right? So yeah, this is p naught upon h cut is the value beta, right? P naught upon, this is going to be p naught upon h cut will get cancelled, m omega h cut, and the 4 is also there, m omega h cut. Okay, this mod square, this will get cancelled because this is m omega upon pi h cut, this is pi h cut upon m omega, and power the same, right? So p naught value is going to be mod square of e to the power minus p naught value is given, guys, right? P naught value is given, so okay, we'll write it later. Okay, so this is going to be e to the power p naught upon 4 m omega h cut, p naught upon 4 m omega h cut, okay, whole square. So p naught is, this is real value, right? So p naught value is going to be e to the power minus p naught square upon 4 this is going to be correct. So this is going to be e to the power minus 2 p naught upon 4 m omega h cut, right? So this, and p naught square, this is p naught square, this one. Okay, because it is guys, this one here we have made one thing. This is b square upon 4a, right? So this is b square means this one, p naught square, and p naught square upon h cut square, p naught square upon h cut square. Okay, so here this will be p naught square, right? So this is 2 will get multiplied, 2 p naught upon m omega h cut, right? So p naught is going to be e to the power minus p naught square upon 2 will cancel for 2 times, and m omega h cut. Since p naught value is given root m omega h cut, right? This is given in the question, guys. This momentum particle gets, right, this one. So this means p naught value is going to be this e to the power minus p naught square, this is e to the power minus m omega h cut upon 2 m omega h cut. This will get cancelled, and this is going to be e to the power minus 1 upon 2. So this is the value, guys. Okay, so this is the value. Which option is matching? So the probability that particle remains in its original state, okay, is that e to the power minus 1 by 2. So which option is matching? Let me check. Option D is the correct option, guys. Okay, option D. So the probability that the particle will remain in its original state, original ground state, will be e to the power minus half. So this is the answer, guys. E to the power minus half. So this is the answer. Next question, guys. Very good question. Okay. Next question is, a polymer question 2, a polymer made up of made up of made up of n monomers a polymer made up of n monomers is in thermal equilibrium is in thermal equilibrium is in thermal equilibrium at temperature T1 at temperature thermal equilibrium at temperature T. Each monomer very good question. Each monomer could be of could be of length A, could be of length A or 2A, length A or 2A. The first contributes zero energy. The first contributes zero energy, while the second one contributes E energy. Okay, E energy. The average length the average length in units of Na of a polymer of a my apologies polymer of the polymer of the polymer at temperature T at temperature T equal to E upon Kb. E upon Kb is okay. Options are 5 plus E upon 4 plus E. Option B is 4 plus E upon 3 plus E. 4 plus E upon 3 plus E. 3 plus E upon 2 plus E. 2 plus E, and D is 2 plus E upon 1 plus E. Okay, so this is the question, guys. Okay, I'll explain the question. Okay, question is a polymer made up of n monomers. So polymer is made up of of n monomers. Okay, so there are n monomers which makes a polymer. Okay, monomers is in thermal equilibrium at temperature T. Okay, so that polymer is thermal equilibrium with temperature T. Each monomer could be of length A or 2A. So the length of each monomer could be of A or 2A. It could be either A or 2A. Okay, the first contributes zero energy, means the monomer whose length is A, that contributes zero energy. Okay, so energy is contributed by the monomer of length A is 0, while the second one contributes E, means the monomer whose length is 2A contributes energy E. Okay, so the average length in the units of Na, n is number of polymer. Okay, uh, so the average length in units of Na of the polymer at temperature T is given. Okay, so average length we need to find out. So very good question, guys. I'll explain it, okay, in detail. Okay, so first, guys, we'll write the length of monomer. Okay, the the length of monomer. Okay, or when the length of monomer when length of when of monomer length of monomer is A. Okay, in that case energy is 0, right, as per the question. And when length of monomer is 2A, in that case energy is E. Okay, so this is what given. So now we'll find we know the formula, right? So that probability of monomer. Okay, probability of monomer whose energy is E. Okay, so probability of monomer whose energy is E is going to be, there's a formula, that probability we need to find out. Probability whose of monomer whose energy is E, that is equal to, that formula we know, GI e⁻ beta EI upon sigma GI e⁻ beta EI. This is the probability formula, guys, right? You need to note down. So probability formula, that probability that the probability of monomer whose energy is who contributes energy E is going to be GI e⁻ beta I upon sigma GI e⁻ beta EI. Okay, so now we will find. Okay, so now, and here we can see this is the here we'll find first this, that P, probability of monomer who contributes zero energy, okay, equal to 0. That probability of that monomer which contributes zero energy equal to 0, that is going to be that GI value is 1, guys. Here GI value is 1, non-degenerate case, right? GI value is 1. Okay, so this is 1 into e to the power minus beta ei. E is 0, right? E is 0, so e to the power minus beta into 0 upon sigma gi means 1 into e to the power minus beta into 0 plus 1 into e to the power minus beta I. Beta e, just beta e, because there are two monomers, right? One has length A, another has length B, and one contributes 0 energy, another contributes energy E, right? So if you solve it, this is going to be e to the power 0 means beta and 0, e to the power 0 is 1, right? So this probability of monomer which contributes 0 energy, that is going to be 1 upon, this will solve it. So e to the power 0 means 1 plus e to the power minus beta I, right? So this is going to be 1 plus e to the power minus beta I. That is the probability of monomer contributes 0 energy. Okay. Now second we'll find probability of monomer which contributes E energy. Okay, E equal to E energy. So that is going to be, this is going to be G is 1, Gi is 1, right? E to the power minus beta E, because it contributes energy, right? Beta E upon sigma Ei Gi, that is 1 plus e to the power minus beta I. Okay, so this value is going to be e to the power minus beta E upon 1 plus e to the power minus beta I. So this is the P. Okay, so now we have got probability which contributes 0 energy, probability which contributes energy, right? Now we will find length, guys. This is very important formula, you need to note down. Okay, so average length formula is going to be L is that is NA into P, NA into P epsilon E equal to 0 plus 2NA P. Okay, so this is the average length formula, guys. You need to note down. Okay, very important. So average length is that because there are n polymers, right? And and which is made up of n monomers, right? And monomers could be of length A or 2A. So then the average length is going to be Na is the length of polynomial. So this is n into, that is total number of polymers. N into A means polymer whose length is A into the probability whose length probability of polymer whose length is A, okay, and which contributes 0 energy, right? This probability plus 2Na into P, the probability of monomer which contributes equal to E energy, right? And the length of that polymer is so length of that monomer is 2A, right? So 2A into N, because there are total number of particles, total number of monomers are N, right? This formula is very important formula which you need to know, guys. So Na P at E equal to 0 plus 2Na P at E equal to E. So this is the important. Now we can just put the value and we'll find the average. So L is going to be this one, Na into P0 is 1 upon 1 plus e to the power minus beta I plus 2Na e to the power minus beta I upon 1 plus e to the power minus beta I. Okay, this is the one. Now P is given because we need to find like this, right? This one. The average length we need to find out at temperature T equal to epsilon upon E upon K. K is the Boltzmann constant, right? So since T is E upon K, right? And A upon K. So and since we know beta equal to 1 upon Kt, or we can write 1 upon K, and T value is this E upon K will get cancelled, right? So beta value is going to be 1 upon E. That implies beta E value is going to be 1, right? So now we can put beta in place of beta E 1, right? So the average length is going to be Na upon 1 plus e to the power minus 1 plus 2Na e to the power minus 1 upon 1 plus e to the power minus 1. Okay, so we'll solve it. So this is going to be so average length is will be, that is L, that is going to be Na, we can take common. Okay, so this is going to be, we can take this 1 plus e to the power minus 1, right, as a LCM, and this is going to be 1 plus 2 e to the power minus 1. Okay, Na we have taken from, this is the 1. So this is going to be Na into 1 plus 2 upon E upon 1 plus 1 upon E to the power minus 1. We can write like this, right? So this value is going to be Na, so E plus 2, this is going to be E plus 2 Na into E plus 2, and this is E plus 1. E will get cancelled, right, into E plus 1. This is the answer. So in units of this, the L is going to be E plus 2 upon E plus 1 in units of Na. So E plus 2 upon E plus 1. So which option is matching, guys? Option D is the correct option. So option D. So this is the option D, guys. Okay, this is the correct option. I hope, guys, you have understood it. Okay, so next question, guys. Question number 3. These are part C questions and lengthy questions, guys. Okay. Question 3 is, this is also a very good question. Okay, the figure below shows the figure below shows an ideal capacitor, an ideal capacitor. The figure below shows an ideal capacitor consisting of two parallel circular plates of radius r of radius r. Points P1 and P2 are points P1 and, I'll make a diagram. Okay, then it will clear your all doubts. Okay, so point P1 and P2 are at point P1 and P2 are at a transverse distance are at a transverse distance transverse distance transverse distance r greater equal to r. Okay, transverse distance r1 which is greater equal to r from the line. So r at transverse distance r1 which is greater equal to r. Okay, from the line from the line from the line from the line joining the line line joining the line joining the line joining the centers of the plate centers of the plate centers of the plates lines joining the centers of the plates while points P3 and P4 points P3 and P4 are at transverse distance are at a transverse distance a transverse are at a transverse distance r2 less equal to r2 less equal to r. Okay, if the bx denotes the bx denotes the magnitude denotes the magnitude of the magnetic field magnitude of the magnetic field magnitude of the magnetic field magnetic fields at these points magnitudes of the magnetic field at these points at these points which of the following which of the following which of the which of the following which of the following which of the which of the following which of the following holds which of the following holds which of the following holds while the capacitor is charging. Okay, holds while the capacitor is charging the capacitor is charging is capacitor is charging. Okay, options are option A is P1 greater equal. I'll make a diagram. Okay, after that it will clear your doubt. So BP1 greater equal to BP2, BP2 means magnetic field at P1 greater equal to magnetic field at P2, and BP3 BP3 less equal to BP4. Okay, option B is BP1 greater equal to BP1 my apologies, greater than BP1 greater than BP2 and BP3 greater than BP4. Option C is BP1 equal to BP2 equal to BP2 and BP3 less equal to BP4, and option D is BP1 equal to BP2 and BP3 greater equal to BP4. Okay, so this is the question, guys. I'll make a diagram, so then I'll explain the question. Okay, so this is two capacitor is given. These are two capacitors, circular capacitor. Okay, these are circular. Okay, this is radius is R. Okay, and the line this is joining line center. Okay, and at here there is a point P1, and at this point there is P2. Okay, and this transverse distance from the line joining the centers of the capacitor, this is R1. Okay, this is R1. This is R1. And there is another point which are given like this. So here there is a point P3, and at this point there is point P4. Okay, so these 4 points are given, and this is the parallel plate capacitor, circular capacitor. Okay, and this distance is these points distance from the line joining the centers of capacitors is this R1, and this distance is R2. The transverse distance of P3 and P4, the line joining from the center of the joining the centers of the capacitors, that is R2. Okay, this is what given. Okay, so I'll explain question first, and after that I will solve it. Okay, So question is, the figure below shows an ideal capacitor consisting of two parallel circular plates and radius r. Okay, so this is two circular parallel this is the capacitor. Okay, so the ideal capacitor consisting parallel circular plates. Okay, so this is a capacitor consisting of two circular capacitor parallel plates, circular plates. Okay, next is the radius is r, guys. Okay, so radius of this and radius of this is r. This is what given. Point P1, P2 are at the transverse distance R1, which is greater than R from the line joining the centers of the plate. Okay, so P1 and P2, this P1 and P2 are R1 distance, the transverse distance from the line joining the centers of the circular plates. Right? This one. While the points P3 and P4 are the transverse distance R2, okay, which is less than R, okay, this one. So point P3 and P4 are transverse distance. They are at transverse distance R2. Okay, so this means the distance of them from the line joining the centers of the circular plates is R2 for P1, P3 and P4. Okay, so this is the circuit given. Now, if the Bx denotes the magnitudes of magnetic fields at these points, which of the following holds the capacitor? Which of the following holds while capacitor is charging? Okay, so while capacitor is charging, so these are the options given, and we need to choose the correct option. Okay, so very good question. Okay, so this is the figure, guys. Okay, so now so guys, we can see here in the figure, right? We can see P2 and P4. We can see they are outside the capacitor, right? It means we can use Ampere's law and we'll get the magnetic field at P2 and P3. Okay, so we'll write, since magnetic field at P2 and P4, magnetic field at P2 and P4 at P2 and P4 can be simply P4 can be simply written can be simply written using Ampere's law